like some of the factoring ones, whenever we divide, we're just really going to factor whatever we have out. Okay, factoring and dividing is really the same thing, or it's very similar. It's just we're not going to actually get everything out. Whenever you factor anything, you're basically dividing whatever it is in the parenthesis, or whatever the whole thing is, by whatever you factor out, leaving you with whatever's in the parenthesis. So like if I have 13t plus 39y, what number can I factor out of each, the 13t and the 39y? A 13. So if I can factor out a 13, essentially what I'm doing whenever I factor out the 13 is I'm dividing 13t by that 13, leaving me with just what? T. Doing the same thing, I'm going to take that 39y, I'm going to divide it by the 13, leaving me with a plus 3y. Okay? You've essentially been dividing polynomials, or you've been dividing things out all the time. Okay? Even though you don't know it. So even like on 3k squared minus 3k, what can I factor out of each part? A 3k. So then what is 3k squared divided by 3k? Just k. What is, so a negative 3k divided by a 3k? A negative 1, right? Okay, so like if you need to actually see it, if I have negative 3k divided by 3k, the only thing I have left there is that negative 1. That negative 1 is right there. So whenever we divide polynomials, okay, there is long division and then there's synthetic division. Okay? Long division is a lot like your quadratic formula in terms of it's always there and you can always do it by long division. So if you're dividing any sort of polynomials, you can always use long division. Okay, we actually just got done doing this type of stuff with my pre-calc kids last week, and they're actually going to test over it tomorrow. So whenever we do long division, okay, so over here off to the side, I'm going to kind of do, remember whenever you were probably in maybe like second, third grade, I don't know, something like that, and you started doing division and you had a number like 2,437. And your second, third grade, fourth grade, I don't know, whatever teacher told you, divide this number by 16. Okay, this is before you dealt with decimals, right? So what did you do? How did you solve like 2,437 divided by 16? What did you do? Right? You looked, because it couldn't go in the 2 because it's too big. So how many times could 16 go into that 24? One time. And you would just put it basically over that value, right? So what would you do within the 16 and the 1? You remember? You multiplied it, so I had 16 right here. So then what did you do with the 24 and the 16? You subtracted it. You changed that sign. So then we got 24 minus 16, and we got an 8. Then what did we do? Yeah, you drop the 3, okay? Drop it like it's hot. So now what? Now you have an 83. So now what do I do? 16. I do the same thing again, but now I'm doing it with the 83, right? So now I'm taking 83 divided by 16. So how many times can 16 go into 83? 5 times? So now what do I do with the 16 and the 5? Multiply it, so I get 80. Now what do I do with the 83 and the 80? Subtract or change the sign. So then I'm left with 3. Now what do I do with that 7? Drop it like it's hot. Okay? So I have 37. Now what do I do with that 37? Now I have a new number, right? So what did I do? I took the 37, kept dividing it by the 16, right? So it can go in there 2 times, and then I have a 32. Then I have a 5, right? I subtract, change the sign of that bottom number. What did I do with that 5? So I got 152. Now this was before you knew anything about decimals. Yeah, they called it a remainder, right? They would probably say, well, you most likely, probably for your time, you probably went like then, you put an R and then a 5. Yeah? Okay? All right. You just said, oh, I got a remainder. There it is. Okay? Now, whenever you kind of progressed, obviously you went through decimals and stuff like that. Did you ever do like 152 and then just take that 5 and put it over the 16? Did you ever do anything like that? Okay. You just either did a decimal or a remainder. Okay. So the decimal is the same thing as the fraction, right? Whenever you did the decimal, you would just keep dropping zeros, right? Until the teacher said either stop, after 2 decimal places, stop after 3, or whatever. Okay, maybe stop until it repeats. I don't know, something like that. Okay, but whenever we went through our decimals and we would have, we would have 50 and we'd divide 16 by 50 and we'd get a 4 or a 3 rather, and then it just keep kind of going from there. Okay, I think it could go like 3, 7, 5 maybe, something like that. Okay, or 31, I don't remember what it is. Okay, but you stopped and you had that remainder, and it's the same idea here. So now, whenever we do long division, okay, now, if we have long division, the one thing we have to make sure that we deal with is having any sort of placeholder. So, like if it would have said, instead of 2,437, if you would have had, if it would have said 2,037 and divide by the 16, right? Instead of 2,437, it said divide 2,037 by 16. Would you make it look like this right here? Is this what you would do? Would you go, well, 2, 3, 7? Well, whenever you were 2nd grade, you probably didn't have a calculator. So, did you just do, like, if it said divide 2037 by 16, did you write it as 237? No, what did that 0 act as? A placeholder, right? Okay, so if you're missing, so it was a placeholder for like that hundreds place, right? You didn't have any hundreds, but you had a place for it. So whenever you divide, you have to make sure that you have any sort of placeholder. So what that means is if you start, like if I'm going to start with divide 2x to the 4th plus 3x to the 3rd plus 5x minus 1, I have to have every single power of my exponent listed. So I have a 2x to the 4th, so I'm going to start with the 4th power. I'm going to work my way all the way down to where I don't have anything. I just have a constant. Now, what am I missing? Which power am I missing on the x, or for the first example? I have an x to the 4th, I have an x to the 3rd. What don't I have? I don't have an x squared, right? I have an x to the 1st, and then I have a constant. So whenever I do this, okay, what's going to happen? I would write this towards the middle for kind of the way that I'm going to show you to do this. So I have 2x to the 4th plus 3x to the 3rd. I have to put in my placeholder of 0x squared plus 5x and then minus 1. I don't have an x squared, but I still have to list it. I still have to have that placeholder. Okay, so if I'm going to divide by x squared plus 3x plus 2. Same goes for anything outside as inside. If you're missing something, you need to have a placeholder. Okay, if you don't have a placeholder, then a lot of things can kind of get messed up from there. Now, whenever we do this, whenever we divide, the easiest way that I have found for students to divide is basically to do like short little problems instead of trying to do, it's called long division for a reason, because it's going to take you a longer amount of time. Okay, but whenever we do it, if you just shorten everything down into small little problems, it'll make it a lot easier. Okay, because then you're not trying to look at the whole thing, you're just looking at each individual part. We take the same concept that we had over here, and we're just going to apply it to what we're doing over here on the left side. Now, whenever I do this, I always look at the lead number. Okay? The lead number underneath or in the house or underneath the box, whatever you want to call it, is going to change. Your lead value out here will never change. Okay, so all I'm going to do, the first thing that I'm going to do is I'm going to take 2x to the fourth. I'm going to take 2x to the fourth, and I'm going to divide it by x squared. So what's 2x to the fourth divided by x squared? What am I left with?
2x squared.
2x squared. That 2x squared is going to go above the x squared that I have in my house. Okay? So it goes above. That's why, again, why I need that placeholder. It's going to go above that 0x squared. Now, all I'm going to do with this 2x, and this is why I just basically write everything out to the side. I'm going to multiply that 2x squared by x squared plus 3x plus 2. Just like I multiplied 1 times 16 and I got the 16 underneath the 24. It's the same idea. Whatever I get there, I'm just going to put it right underneath here. So 2x squared times x to the second is going to be 2x to the fourth. 2x squared times 3x is going to be a positive 6x to the third. 2 times 2x to the second is going to give me a 4x squared. Questions there? Earlier, I subtracted, right? Or I changed the sign. I kept saying change the sign instead of subtract. I like change the sign a little bit better because then if we change the sign of everything, what's 2x to the fourth minus 2x to the fourth? Nothing, right? That's what we want to happen. We want things to go away. So now, so that goes away. So now I have 3x to the third minus 6x to the third. What's 3 minus 6? Negative 3x to the third. 0 minus 4x squared, so negative 4x squared. Just like I did with that 3, what do I need to do with my 5x? Drop it like it's hot. That sign, so that way I knew that every single sign had to be changed. I don't like to multiply by the opposite and all that. I like to multiply everything like normal and then just go back through and just flip signs. Okay, I feel like with high school students especially, there's a lot less chance of you making a mistake if you don't switch signs until the very last thing and then take everything straight down. So now I have 3x to the third minus 4x squared plus 5x. I have a new lead value. So now I'm going to take that negative 3x to the third and I'm going to divide it by x squared. Whatever my new lead is, I just divide it by whatever the lead is out front. So negative 3x to the third divided by x squared is going to leave me with what? Negative 3x. Now, where does that negative 3x go? Right above the x that I have inside my house, so negative 3x. What am I going to multiply negative 3x by? X squared plus 3x plus 2. Where's that going to go? Right underneath what I have here in green. So negative 3x times x squared is going to be negative 3x to the third. Negative 3x times positive 3x is going to be a negative 9x squared. Negative 3x times a positive 2 is going to be a negative 6x. Now, before I take everything straight down, what do I need to do with all that bottom row? Change the sign. So that's a plus. That turns to a plus. And this one turns to a plus. What's going to happen to my what's going to happen with my x to the thirds? They're going to go away. That's, again, what I want to happen. So then, negative 4 plus 9 is going to give me a positive 5x squared. 5x plus 6x is plus 11x. Last thing I need to do, drop that negative 1 like it's hot. Now, we're almost done. Okay? We're starting to run out of roof up on top of my house, right? Okay? That's why I would suggest always putting whatever power it is above whatever power you have. So that way you kind of have an idea, how much longer am I going to have to go out? Well, in this case, I'm going to have one more spot. So I'm going to take, now I have a new lead. So my new lead is 5x squared. So I'm going to take 5x squared divided by x squared. What's 5x squared divided by x squared? 5, right? So I'm going to put that 5 above the negative 1 up on the house. What do I need to multiply the 5 by? X squared plus 3x plus 2. Again, it's going to go right back here. So 5x squared, 5 times x squared is going to be 5x squared. 5 times 3x is going to be plus 15x. 5 times 2, positive 10. Before we bring everything down, what do I need to do with that bottom row? Change the sign. So whenever I do that, what happens to the x squareds? They go away. So I'm going to have a positive 11 minus a 15x. So negative 4x minus 11. I don't have anything else to drop. So what is the negative 4x minus 11? It's my remainder. So all I'm going to do is take whatever I have. I'm going to take this part of my remainder, and I'm going to go plus negative 4x minus 11 all over x squared plus 3x plus 2. This is my final answer. Now, I have no issue in you factoring out the negative and you rewriting this. You can also write it as 2x squared minus 3x plus 5 minus, and then have 4x plus 11. Just make sure if you change one sign, you change them all, and have x squared. You only change the top. You don't change the bottom. Now, the biggest thing with any of these, if you notice, everything I do, I know it's long. That's why it's called long division. Okay, and we went fairly slow. The biggest thing is, the one thing I can stress and really tell you to try to do is over there to the left is, one, give yourself a little bit of room and just kind of work individually. Okay? I would draw arrows, I would circle things, so then you know what you have to do. Okay? If you just try to go, in some cases you're going to get really kind of, if you don't kind of organize everything, then it can really be a stressful process. I would strongly urge you to kind of do everything nice and short and simple, and then work your way from there. Okay? Not try to look at it as one big, long, huge problem, but to simplify it and break it down into, in this case, 3 little parts. Okay? Instead of one big problem, make it into 3 little small problems. Okay? And then just put all the problems together. Okay? You can't forget a placeholder if you need one. If you don't need one, you don't need one. But if you're missing a placeholder, like where it says you try on number 1, there's no placeholder, you're just going to go. Okay? You're just going to start with what you have and go from there. Whereas on number 2, you don't have an x to the third, you're going to have a placeholder in there. Okay? So pay attention to if you need a placeholder or if you don't.